Hi everyone, I'm David Reeves. I'm not like the other presenters here today. I'm not an expert in the industry. I'm actually a student. I'm actually a first year student in my first semester studying computer science. And what I want to talk about today is a tool that I've made in my own time with my own initiative. No one's told me how to do this. There's no right or wrong way, in my view, of what I'm doing. And my end goal, if I can describe it like this, is can you imagine living in a world where hacking is no longer an issue that people worry about? That's something I'm working towards. That's what I want to. That's the kind of future I want to live in, because to be honest, security on the internet is not good. Maybe, you know, in corporations where people know what they're doing, it's not bad, but for the average user, it's really not a good situation. So DYNAFA is a firewall which can change over time, as implied in its name, and therefore it limits the ability for adversaries to see what's going on within the router. So basically, internet-based attacks, they work on port scanning, phishing, you know, getting an IP, having a look at it, finding a vulnerable service, and I've tried to eliminate that. So why did I make it? I want to make a 100% impenetrable network. So the fundamental aspects of it is address lists. So I utilize MikroTik, dynamic address lists, and the way that I've laid it out means that you can actually choose the parameters in which your firewall is based on. So I think unpredictability is a huge tool in securing a network. So in addition to that, actually create an unpredictable mathematical relationship between the authenticator and the public-facing interface. And then you have an authentication process, which is handled by SYN packets, basically port knocking. So what I've done is I've taken a whole lot of things that I've found from the MikroTik wiki. Basically, I've only actually learned MikroTik in my own time for about a year, and at the same time I learned about Linux for about a year. And then I have the firewalls, firewall rules, which I can change through scripts. So that gives it some basic characteristics, which is it minimizes the attack surface significantly. That's a huge thing, because, you know, with the way that hosts are set up, it's really easy to find services running if they're on dedicated ports. It's not hard to find some way to get into a machine. And I've actually thought of it from a hacker's perspective. What would a hacker be looking for? And how can I counter that? So port scanning and replay attacks, I've focused on a lot to try and reduce the risk from that, and actually put some poison ports in there. So using blacklisting to get rid of people straight away and filter out packets efficiently. That means that it's almost nearly impossible to use brute force on the system. So if you do a comparison between having no security whatsoever and having basically no in or out, you have some simple brute force protection. So maybe you use some recommended method of adding someone to a blacklist if they're sending too many new SSH packets to form new connections. This is not really effective in my opinion, because you're inviting people to come right to the front door and actually start an attack. What I think is a good security policy is actually try and prevent attackers even launching any kind of thing at your network. So basically why I made this in the first place was that I was study. I had a web server. I didn't want anyone looking at it while I'm not there. So I thought about how I could achieve this, and I actually made my first version of DYNAFA in one weekend. I wrote the algorithm in 4 days to generate the numbers, and you're probably thinking, why don't I use IPsec and tunnel into the router directly? It's pretty secure. And the answer is I don't know how to do it. So, and basically this is how it works. You have an instigator of change, and that can be either the router itself, you can use scheduler, you can use a local host and execute scripts which will change those file rules, or you can do it from the machine that you're on. And what happens is that you actually have a continuously changing firewall, and that means that the authentication packets are very, very hard to send correctly without knowing what's going on, especially how it's changing over time. That makes it very secure. So here you can see this is actually what it might look like if you're looking at the predefined range. So you have the yellow ports there. Those are the ones that are actually responsible for adding the IP to the right to the address list to get onto the secure address list to actually access any services on the router. So obviously it's very hard to actually not only get the right ports, but get them in the right sequence. And I'll talk about some probabilities of that later on. So yeah, like I said, you can actually control it from either your local address, a local host, or a remote host, and use these kinds of methods. So implementing it, I actually just do it over Linux command line. I haven't written any application to do that. I've done it, overall I've worked on it for about 8 days. And so what you do is you basically set up the firewall rules, you generate a unique number set, and then you apply those values by using a script. And I'll show you the website that I set up. So what I'm doing here is this is the number generator, and this code's available at dynafa.com. I want you to have a look at it if you're interested. I think it's great to put code out there, make it open source. Get feedback from other people. And so you can see here, you can put in the parameters, and basically it works out the range, and you could do it, 30 rule sets by 5 or whatever you want. I've done it. I've made 48 ports, and I've actually embedded the service ports and a backdoor into this design here. And basically, you can just keep generating numbers until you're convinced that it's absolutely random. And this is the algorithm that generates the numbers. It's JavaScript. I taught myself how to do all this. You can use scheduler. This is an example of just a basic script to change the firewall rules in order to get the correct effect. So you can use Chrome tab from localhost, and basically you can copy all this straight into a script and run it on the command line. And you can see here, you actually it automatically creates these scripts here, and I've created a cloak to try and mitigate replay attacks. It's not really effective if someone's already in the middle, but it's just some kind of experiment that I've done. And if you want, you can go and have a look at all my firewall rules. I won't get bogged down with that. But moving on. So here's a kind of overview of how I see the system. So you have your surface of the interface. You have 65,000 ports on any connection and on any interface. And then you actually have an aperture, so you have a reduced surface area. And then if you imagine that it being linear but actually connected to a matrix, which is technically it's a Markov Chain, which is a continuous stochastic process, and that relationship is very, very complicated. That contributes a lot to the security of the system, and as you go through these rules, you have to satisfy the authentication requirements to actually get in. That's part of the security as well. So if you just imagine the Enigma machines, this is kind of what I've been inspired by, because obviously a huge tool during World War II. It's very important, and someone actually cracked this. So and here's the way the firewall filters packets. So basically, I've simplified it here, where you have either input or something going to a service that is known off. So if someone sends a packet to a host that they want to connect to, they have to be on the secure list. Otherwise, they're just dropped. But if you look at what it takes to get onto the secure list, you have to get in the right range. You have to match the right port, and then there's basically one way to get in, and that's by finding access port number 1, and henceforth you actually get to access 2, access 3, and then secure, and it's very, very hard to do this just by chance. So if you look at the probability of it, 1 in 65,000, if you say this is A, then it's 1.53 to 10 to negative 5% that you'll guess it randomly. But if you put A to the power of 8 or to the power of 4, it becomes almost impossible just to do this by brute force. And then say that actually some adversary figured out which 4 ports they might need to send SYN packets to get in. Well, then there are 24 different combinations. But if you have a backdoor, then the probability of guessing the backdoor is actually 40,000. And if you consider that they might think that your authentication chain is 12 long, well, then they have 480 million different combinations. It's kind of like playing Minesweeper, except a lot harder. And there's no clues as to actually where you might access it from. So I actually want to show you something, some simulated attack of my router. So here I am on Kali Linux. I've got 2 MikroTik routers. I'm using one to ping the other so that I can see if I'm blacklisted or not. And I'm going to start throwing all that I can from Nmap to see what happens, just to see if I can get in by brute force. Obviously, just 4 port scan, nothing. 100 port scan, nothing. And sooner or later, you're going to see it blacklisted. It will time out because you're going to hit some port, and there you are, blacklist. So remove it and start again, because basically that's game over for anyone trying to attack me with their map. And I actually have ever since I put this system up, I've had a botnet from Russia scanning me every day. There's about 6 bots at the moment, continually trying to break in. They're going to be really disappointed when they find out it's just a $200 computer from China running Node.js for my course. But yeah, basically, I've tested almost everything, and if you want to attack my router, you can get my IP. I welcome any kind of stuff like that. So really, what the security system depends on is infinite randomness. So a continuous stochastic process, like I said, a Markov chain. And if you actually look at the algorithm of how I created these numbers, basically you can describe it as if you take ABC, which is your maximum, your phases, and your steps, and you derive D and E from those. Well, then you basically run a for loop. You generate a whole lot of random numbers until you fill up this array here, and any number in this array can be described as either e plus n or a minus n, where n is a random number, basically put through some equation so that every port is filled, as you see in the web browser application. So this is just if you imagine that an adversary has thousands of IPs to expend to the blacklist, they find the range and they have a look. Basically, any port that's on part of the authentication, it will show up as closed. Anything else is filtered. And if you have a look at what happens when you put a backdoor in with a whole lot of service ports, well, you have, I don't know what there's 20 or 12 or whatever ports. As I said before, 480 million different possibilities. It's not likely they're actually guess from this alone. So there's other ways you can counter this. You can use a VPN if you're on Wi-Fi. You don't want Wi-Fi sniffers having a look at the headers to figure out what you're sending. You could send fake packets to cloak the real ones. I'm actually doing a degree majoring in AI, so I'm actually going to take this idea and really look into some of the more commercial applications develop, like Troy Wilkinson mentioned before. It's really interesting. That's where I want to head. I think if I can achieve this much in 8 days, I can probably achieve a lot in 3 years. So there's some other ways you can manually blacklist known threats. You can never use the same sequence twice. So just use one set and then change it, and really no danger in replay attacks. So what I want to do is actually educate people, common people, about security. It's a really serious issue. I want to continue researching botnets, Russian hackers, stuff like that. And I want to continue developing security software. I think there's a huge demand for that. I think I'm really passionate about that. I want to help people be secure, not just a single country, a single company. I want everybody to be safe on the internet. So Dynabot, DYNAFA version 2. I won't go into it because I might give away another good idea. But it's exciting. So you can go to dynafa.com, have a look for yourself. Email me. I really appreciate any kind of feedback from the industry. That's why I'm here. Cool. Thanks a lot. Are there any questions?
Sorry, wait for the microphone, please.
Yeah?
If you spoof your source address, can you block legitimate sites?
Yes, you can. That's what the Russians have been doing to me.
They spoof your DNS servers or something.
They're too lazy to use spoof MAC, so I can actually correlate their MAC address with their other hacking attempts that they've done. So I don't know why, but they're blocking my flatmate from accessing Google. Yeah, that's the only weakness they could find in it, basically. Yeah.
Yeah, but it's quite a serious weakness.
It is, yes, but it's only an idea.
How did you encourage Russian hackers?
Nothing. I did nothing. They just started scanning me. I don't know. Thank you.